I think I'm streaming. Hey everybody, welcome, good morning. I've been having technical difficulties for like the last 20 minutes and I think this is actually working. Oh my God, it's working. YouTube changed the way things work. Good morning, welcome. This thing is called the Coding Rainbow. I had a whole thing prepared to say that I don't have prepared to say anymore because I just spent 15 minutes trying to make all this stuff work and I feel very stressed out. But I'm here in New York City at a place called ITP at New York University, Tisch School of the Arts, and I'm here to talk about, I have a prop, the Microsoft Kinect. How do you program with this thing? How do you do interactive stuff with this thing? How do you use this thing with something called processing, which is running behind me here? Oops, I didn't even configure my window or anything. So people in the chat, tell me if you are there. Tell me if you can hear me. Tell me if you can read this font. Tell me if you can see me over here. I need to test to make sure this whiteboard is working. I mean, the whiteboard is working, but if the focus is pretty decent, I think that's pretty good. I'm going to walk over here. I've got Periscope live going. Hi, Periscope. So I'm like triple, double streaming something. Hi, I'm talking to Periscope. So now I'm live on YouTube, Periscope. So I'm going to put you down so you can see the URL over here. And you can go there. This is like the most ridiculous thing I've ever done. There you go. Okay, so that's where you can go, Periscope, or you can at least hear the audio. So, okay, everybody can hear me. It works like a charm. That's great. That's exciting to hear. Okay, so I've got to get started. And I think I'll be doing this for about an hour or so. I'm glad to take questions. The first thing I want to do, so I'm kind of going to talk this through first to figure out the kinds of things I'm going to cover. I'll look for any questions or ideas in the chat. And then what I'm going to do, as I always do, but I'll explain it again, is during various parts of this live stream, I'm going to hit a record button to like save a particular chunk as a standalone video lesson, which I will upload to YouTube later. So my goal is to have like 4 or 5 10-minute video lessons about using the Kinect. And this live stream will be kind of a mess of like trying all sorts of stuff out and in between making those videos. And sometimes I stop and start and redo the same content if I feel like I went in the wrong direction. And so you just turn it off if this is like driving you crazy. So I'm checking in the chat. Hello, Cardiff again, and hello, France. One thing that's really important, if the audio stops working or if some weird thing happens you can't see me, please type that in the chat. I'm not doing anything with Twitter today, so I don't need people to tweet while I'm doing it. But welcome to let people know this is happening. It's a holiday tomorrow here in the United States called Thanksgiving. NYU is actually closed today, but it's a busy, active time because it's the end of the semester. So, but the reason why I'm doing this actually is because a lot of students are trying to do projects with the Kinect around here, and I thought this would be helpful. We'll see. Okay, I'm going to drink a little water and get set up. So I think the first thing that I'm going to do, is just talk about the Kinect in general, what the different versions of the Kinect are, how it works, and show you how to install a library in processing that uses the Kinect. Open the window for a minute to get some cool air in here. Lights, so I'm going to get a little bit hot. So I'm going to just talk about the Kinect in general and like run some examples to show what it does. And then I am going to try to look at a few different scenarios. For example, finding the closest thing, maybe, to the Kinect. Maybe finding the top of a human being, like where's the top of your head. I want to look at like taking the depth map and maybe just like dividing it into sections like a grid. Somebody had an idea for a project at ITP, which is to have like the Kinect pointed at a sandbox, and you could manipulate the sand, and the height of the sand would play different musical notes. So maybe some kind of, I don't have a sandbox, and I have the Kinect in sort of a weird place. So I don't know how this is all going to go, but I want to try to build a few examples from scratch, basically, while we're here. Okay. Great. I'm seeing some nice people say hello. Yes, if you're listening to the Periscope audio and the YouTube audio, you're in trouble because they're definitely going to be out of sync. And that's that. So let me get myself a little bit oriented here. And I'm going to, so here, by the way, so let me see. So let me get this particular example up and running. I'm going to hit stop. I need a little bit more room here. I'm going to do this. Interesting. I don't think I actually need this statement in there. And I'm going to do this. And okay, so this is the first thing that I'll just talk about, which is that you can get the regular image from the Kinect, the depth image, which you can see the darker the color is, the closer it is. This is using the Kinect version 2. There's what the camera is actually seeing, the infrared that the camera, the sensor, the Kinect, whatever you want to call it, is seeing, and the this thing called a registered image, which aligns the colors with the depth. Okay. I think it runs on Linux. I don't know. That's a good question. I mean, so a lot of this work I have to credit Thomas Sanchez Lengeling. Does anybody know how to pronounce his name? Let me pull up the person I would like to credit for a lot of this work, who helped have the library work with the Kinect version 2. Thomas Sanchez Lengeling. Here he is. Código Generativo is his website, which I'm probably butchering the name. So what works in portfolio of Thomas Sanchez Lengeling. If anybody knows how to pronounce that, so write it phonetically in the chat. Otherwise, I'll probably mispronounce his name. But I do want to thank him when I start making some of these videos. I guess this is a video I'm making right now. I'm already thanking him. But he's done a lot of work with the Kinect and in this particular library. So what I should probably bring up here is Open Kinect for processing, the GitHub page to look at this, as well as, sorry, I'm just getting set here to make this first video. The Open Kinect for processing, and then this is my page, which could use some work, but it has some documentation and stuff about it as well. Okay, yes, you can install the Kinect library directly from processing, and you don't need to install anything else. Unless you're on Windows, maybe you do, but you follow the instructions. Okay, so I'm getting ready. I'm going to make this first video. I'm going to just drink a little bit of water over here. Wow, I've got 31 people watching. That's fantastic. I'm actually just going to send a quick email to ITP students because, hold on a sec, because a lot of them were interested in maybe joining. So live stream on Kinect happening now. Okay, I'm just sending that out. Okay, so I think I'm good to go. Wow, I just took, it's all 8 minutes to get started here, but I'm going to open this up. And so in the first video, which I'm about to hit record and do, the things I'm going to cover are how to install the library, what the different versions of the Kinect are, the hardware, the different editions, and which ones work and which ones don't work. Maybe they all work. And then the basic functionality of the Kinect in terms of the pieces of the things. The RGB image, the infrared image, the depth image, the raw depth data, and the registered image, which is only part of the Kinect version 2. So that's what I'm going to cover in the first video section, and then in the second one I'll probably do some type of visualization of the depth data, something like that, okay? So it's your last chance to ask a question in the chat. Oh, a lot of you might be interested. I just was reminded that there is something called the Key Motion or the Kai Motion or the K Motion, K-I-M-O-T-I-O-N, which is a library framework for using the Kinect with P5.js, which is another programming environment that I make a lot of video lessons about. So don't know if I'm going to get to that today, honestly, because I haven't had the chance to really get it set up and running myself. But I definitely, I imagine this to be a new playlist about the Kinect. I'm going to do raw depth. I'm going to do skeleton tracking with the Microsoft SDK. I'm going to do using probably this KeyMotion thing for P5JS, because lots of other people are making stuff, and I hope to be able to mention those things and help people get started with those things as well. Okay, here we go. In 3, 2, 1, something like that. I need somebody to like be behind the camera going in 3, 2. Except nobody's there. I'm just doing that for myself. My nose is running, but it'll be fine. Okay, click the mouse. Mouse goes live. And hello. Okay, wait. I like lost track of what I was doing. Hello, this is the first video in a series of videos about using the Microsoft Kinect in your own software. And the software I'm going to use is this thing called processing. Eventually, I will also get to looking at how you might use the Microsoft Kinect with P5JS in the browser. But the first, I got to start over. Too long-winded. I've been looking at too much at my YouTube analytics and see how people are watching. They all drop off when I start to ramble at the beginning of a video. But I really shouldn't care about that. I'm way inside my own head too much. I'm just going to make this video. Hello, this is the first video in a series of videos I'm making about the Microsoft Kinect. This thing. So what is this thing? How does it work? And how do you write your own software that makes use of this thing? How can you do all sorts of creative coding projects? Now, there's a lot of different programming languages and environments and frameworks and libraries for how you might use the Kinect. I'm going to use this thing called Processing 3, the 3rd edition version of Processing, which is a Java-based programming environment, open source environment. That there is several different Kinect libraries for. Eventually, I will hope to make a video where I look at P5JS, which is a JavaScript framework for doing creative coding in the browser, and how might you get the stuff from the Kinect. What is this thing called the Kinect in the browser itself, which I think will be an exciting thing to see as well. But in this first video, what I want to do, I'm going to get into the code really in the next video. And what I want to do in this video is give you an overview. So what are the different editions of the Kinect? There's a bunch of different ones that you could buy. What are the pieces that you need? How do you get the library to make use of the Kinect? That sort of stuff. And you can see I have a basic example that's running behind me with the Kinect version 2, and I will talk through the pieces of this code. So first, let's think about the different versions of the Kinect. So this one here. I need reading glasses. This one is the model 1414. This one is and I'm gonna come over here and try not to trip over to myself. And I got to grab this eraser for a second. So let's make a list here. So the two key pieces of information for you are you need to decide, are you using the Kinect version 1 or the Kinect version 2? I'm probably going to get lots of stuff wrong here that you can write in the comments, and I'll put little annotations on the YouTube video that fix them, but hopefully I'll get things loosely right. So the original Kinect version 1, model 1414, is the one that came out, I think it was November 2011, 12, somewhere around there. I remember the weekend it came out, people were quote unquote hacking it, but really just but by hacking it, I mean making open source drivers to read the data, a driver being a thing that your computer runs to talk to the hardware device. And so when that came out, I worked on a library called Open Kinect for processing. And the reason why it's called Open Kinect is because it's making use of the Open Kinect, an open source driver for connecting to the Kinect, which is also known as a libfreenet. So this is sort of the genesis of all of this. The thing that I built for processing is just a thin layer on top of work that lots and lots of other people did, which allows you to get the data from the Kinect. Now, let's come back to the Kinect. What is, it's over here, and then I'll get to the other editions in a second. What is this thing? So this is the original Kinect, and you can see here that there are 3 little circles on here. It's like a nice little friend with 3 eyeballs. And what do each of these eyeballs do? So one of them, if we, camera, shift menu, I suck at making these videos. Okay, I'm going to go anyway. Okay, so this is the Kinect, and it has 3 little eyeballs, one of which is an infrared projector. So this is what the 1414 does, and I'll talk a little bit about any different marker here, what happens once you get to the Kinect version 2, how that works differently. It has an infrared projector which sends out infrared light into the room. Then it has what I would call, you could call it a sensor or a camera, but it has an infrared camera to read the infrared light that's in the room. What is infrared light? It's, light that's all around us but is invisible. Somebody with a physics degree could explain that better. But this is blasting out infrared light. This infrared camera is reading it. So what is the value of doing this? So the interesting thing is the kind of light that it's passing out is actually a whole lot of infrared dots. It's projecting a lot of infrared dots into the room that look like this. And it's a very specific pattern of dots. And the Kinect itself, it knows what that pattern of dots is supposed to look like. So if that pattern of dots, if I have the Kinect here, it's blasting the infrared light, lands on a flat surface, the infrared camera that's reading where those dots landed, that's seeing those dots reflecting back, is going to see like, oh, it matches exactly the pattern of dots that I know. That's a flat surface. But if this surface was curved, those dots will appear distorted. By analyzing that distortion, the Kinect can recognize what things are closer and what things are further away. So the value of this is it is often referred to, you can think of it as a depth camera or a depth sensor. This is what this infrared projector and infrared camera are doing. They're measuring the depth of each pixel in the room. So while a regular web camera says, here's a 640 by 480 image, each pixel has a red, green, and blue value, and it's beautiful, isn't it? The colors of the rainbow are there in this image. The Kinect is saying, I don't see RGB. What I see is I see a pixel, and instead of telling you what color that pixel is, I'm going to tell you how far is that pixel away from the sensor. And this is incredibly valuable in computer vision. One of the classic computer vision problems that people try to solve is background removal. That's why I have this green screen. I have to go underneath this here. Okay, I have an obstacle course in my office. I'm going underneath this to turn this camera back on, and I'm coming back underneath here. I have this. Hello. I have this green screen here behind me that you can see. And so the camera is saying every green pixel, remove it and put the stuff from the computer behind it. But if I had a Kinect, I don't have to say, look for the green pixels behind me. I can just say, look for any pixel that's farther than 2 feet or some amount of centimeters. I'm trying to be metric. I want to be a metric person, but I'm not. So you could remove, you could analyze things. It makes it really easy to find a human being in the room because a human being has a certain kind of shape. It makes it really easy to do quick and dirty 3D scanning. There's lots and lots of possibilities of what you can do once you have access to the depth. Now, there was this third little eye here, and this, by the way, is just an RGB camera. So one of the things the Kinect can also do is just see the colors in the room. So in addition to having this infrared camera, it has an RGB camera. Now there's a bit of a problem here, which is that notice how both of these things are not in the same place. So the infrared camera sees the depth of a given pixel at a different place that the RGB camera sees that color. So this is an alignment problem, a calibration problem, where the color pixels don't necessarily line up exactly with the depth pixels. And there are lots of strategies for solving this problem and lots of frameworks and libraries, in particular the official Microsoft SDK, which has things baked into it that do this for you. But one of the nice things that we'll see once we get to the Kinect version 2 is it has something called a registered image, which is an image that aligns the depth pixels with the color pixels. Okay, so this is what the Kinect does. And I really described here what the Kinect version 1 does. There was also model 1473 that came out, I don't know, a year or two later. This one has some problems. In particular, there's a little bit of a bug currently with running it with the processing library, although it does work. Kind of only will work every other time. Can't figure it out for the life of me. But both of these will work with the library. What you need to look for with the library is the version 1 examples. So that's that. Now, in between here, there was like this Kinect for Windows. And I think this was like a version of the Kinect that the Microsoft made to plug into like Windows computers. Originally, this was designed for use with the Xbox for games that you would play by, you know, dancing. I'm kicking my leg, by the way, if you can't see that. But you know, then Microsoft realized there's I don't know what's in Microsoft heads, but I'm speculating here. But that to make a version that's designed to work with just regular old laptops and computers. I'm not sure if this one works with the processing library, but more recently, and I have this one plugged in and like mounted on the wall over there, so I can't hold it up and show it to you. The Kinect version 2 is a newer and quite significant upgrade from the first Kinect. And it actually uses a completely different technique. It uses infrared light, but it uses a technique called time of flight. So it sends the infrared light out, measures how long it takes for it to bounce back, and how long that takes lets the sensor know how far away things are. Kind of like a bat maybe does stuff with sound to see, I don't know, you know, dolphins do stuff like that, but all with sound. So with light, bouncing it back and forth, the new Kinect does that. And I suppose it's a bit more accurate, it's faster, and the RGB cameras also in the new Kinect is higher resolution. Okay, so that's the basics overview. And if I come back over here, you can see now I'm running an example. I have the Kinect right over here. You can't see it. I could maybe like turn, kind of like if I hold it up over here, there you go, there it is. This is the new one. I'm gonna put it back. That felt like a little scary, like everything was gonna fall over. And you can see now that what you're seeing in this particular image is an example of a processing sketch, which is rendering all of the pieces of what the Kinect offers. Now, but I have something more to mention about this, but I'll get to that in a second. So up top, you can see that's just the RGB image. So it's like I have a webcam over here. I have a webcam over here. Hi, webcam. That sort of thing, right? So that's the webcam. That's the RGB camera, and it's actually, I believe, I didn't actually check, but it's a pretty high resolution image. Down below, this is the raw feed of what the infrared camera is seeing. So this is what the infrared camera is seeing, and it uses that to extrapolate depth. So mostly it just looks like this creepy thing, but you can make use of that. You can get that image as well. Up the top right, this is what's known as the depth image. So what the Kinect is measuring is in millimeters. It's measuring a value between 0 and 4,500. How far is the thing away from the camera? And then often a depth image is used to visualize that data. So in this case, you can see as I start to go further and further back, I get brighter. As I start to come closer and closer, I get darker. So it's mapping the color of every pixel to how far away it is. And you can see just from a standpoint now how much easier that might be to pick out my hand, right? Because my hand is the only thing that has this very, very dark color as opposed to other things. Now, there is something funny in the back. What's up there? Oh, that's a window. I was like, what's that black square up there? That's a window. That's the door. You can see all sorts of things inside this room that you may not have seen before. And then down in the bottom right, this is the registered image. So this is not part of, if you use the version 1 Kinect with the Open Kinect library, this is not part of that. However, with version 2, this is the image that aligns all of the RGB values from the webcam with the depth values. So if you wanted to, hopefully it's something I might be able to demonstrate in some video, is just do background removal where you see only me, and I get rid of all the pixels that are behind me. That might be something that I could do here with that particular image. Oh, the laptop went to sleep. Come back, wake up. Okay, so a couple more things. So what I want to show you now is how do you get this library to run this, like this particular example. So a couple things. One is, I'll put all this in the description of the video. This is the URL. The library is at github.com/Schiffman OpenConnect for processing. You don't need to go to that URL, but that's where the source code is. There's a little bit of documentation there. I want to give a big thank you to Thomas Sanchez Lengeling. I might not have pronounced his last name correctly. He wrote all the code for making this library work with the Kinect version 2. So I worked on the version 1 a number of years ago and sort of floundered, and Thomas came back and revived this and really helped over the summer. And there is also, I have a page that has some additional documentation. It's schiffman.net/p5/Kinect, and this is some text that kind of goes through the different versions and some of these examples. as well that I'm going to cover in the videos. Now, in order to get the actual library itself, what you need to do is go to, first you need to download processing if you don't have that already. That's at processing.org. Then what you'll need to do is once you have processing, it might look just like this to you, something empty. You're going to go to Sketch, Import Library, Add Library. Now you can see that I have 3 libraries here. I already have that library, but I'm going to pretend that I don't for a second. I'm going to go to Add Library, which opens up this Contributions Manager. I can type in Connect right here, and this is something really quite important now to bring up. So there are several different libraries. There is, by the way, something called Simple OpenNI, which is an older library. OpenNI was an open source platform, open source framework for doing skeleton tracking, meaning finding the human form, where the hands are, where the head is, which is very, very powerful in things that you can do with the Kinect. I'm starting with just the raw depth data. But OpenNI, I think, was purchased by Apple and then kind of like shut down as an open thing. But there are some efforts to revive it. And so you could Google around, and that's something that you could possibly use. I'll try to include some links. But you can see that it's currently this simple OpenNI. It's no longer compatible with Processing 3. That's why it's grayed out. Kinect V2 for processing. This is a library that makes use of the Microsoft official SDK. And I'm going to demonstrate that using a PC in a later video. This is a really great thing to use if you want to get all of the magic that Microsoft has spent all this time developing. So what the Kinect just gives you is raw depth data, raw RGB data, but what the Microsoft SDK does is it pulls that data in and it analyzes it and finds where's the human being, like what kind of muscle are they making, like where's their head, like is their hand open or closed, and it's so much sort of a layer of analysis on the raw depth data that will give you a ton of information. So, but for that, you do need to use a Windows machine. Of course, there are some strategies for like sending the data from a Windows machine to another machine through like a WebSocket. What's a WebSocket? All sorts of stuff, but we'll come to that in a later video. So those would be the 2 libraries that, but the library that I'm using today, which is already installed, you can see by the green check mark, you would just need to click it and click this install button, and it would download and install. This is the library I'm using today. It uses open source drivers. It only looks at the raw depth data. So this is good for a bunch of different kind of creative applications that I hope to show you in the next set of videos. So this was a long, rambling 16-minute explanation about the Kinect that you may or may not have found useful or interesting, but I imagine you already turned it off if you didn't. And in the next video, what I will demonstrate is just how to write a program that gets that depth image. And once it, I'm going to bring that back. Oh, it's not running here. Gets that depth image and maybe visualizes that depth image in some way. So that's where we'll start. And then I'll look at a couple other scenarios along the way as well. OK? And so thanks for being here and watching, and talk to you soon. OK, everybody. All right, could people hear me through all that, and that worked and everything? I don't know what's going on. I feel like a little lost here. All right, I'm looking to see if there are any questions. Some people are asking things from various places. I would like to sing a Coding Rainbow theme. Okay, the white line on his shirt. Is there something transparent on my shirt? Oh, there's a green. It's not white. This is I wore this because this is a shirt that I have that has a rainbow on it, and this line right here is green, so it's transparent because it's picking up the green screen behind me. Okay, glad that was helpful. Okay, so now what I'm going to do, I think maybe what I'm going to do right now, you guys, is I'm going to try building a little example, and like to practice, and then I'm going to do the video where I build the example again. So I'm going to do it now with a little less like personality, whatever that means. And you can ask any questions if you want. So I think the first thing to do would be to actually just look at the depth image and then like take each pixel and map its Z location according to its depth. So let me go and grab Open Recent, this one, and I'm going to say depth image viz. So I'm going to make a sketch that's 640 by 480, I'm going to just do this. So I'm just looking at the depth, and I'm going to say p image. So I'm going to explain all this when I make the video, but I'm just sort of trying out to see if this example makes any sense. And then I'm going to say for int x equals 0, x is less than image.width, x plus plus. For int y equals 0, y is less than image.height, y plus plus. I have a syntax error here. And then, can you guys read this font size okay? Should I make it bigger? And then I'm going to take out all of this stuff. And then I'm going to say int index equals x plus y times image dot width, and color, or like depth equals the brightness of image dot pixels at index. Maybe I'm going to turn off the code completion. Oh no, I want that. Oh, I don't know. I'll leave it. It's fine. And then I'm going to have a variable called like w is 10. Oh, maybe I'll call this skip. That's kind of useful. Skip plus equals skip. And then I'm just going to draw a rectangle at x comma y, skip, skip. And I'm going to say fill D, and I just want to see if this works. Whoa, I'm missing a semicolon. So I'm just trying to like make it a grid here. What did I miss? Image.load pixels. Image.load pixels. Oops, I have a capital I there. Someone's asking a really good question. I totally should have mentioned that in the video. You do not need to install any extra drivers or anything. It just works. The idea is the library just works right out of the box. Yeah, so most of the time when you're working with the Kinect, you got to install all this other stuff. Maybe I'll I don't know, I'll have to put that in an annotation in the video because that was like kind of a big thing that I missed there. I should just remake that one, but it was too long. Okay, what did I miss here? Array index bounds, array, x plus y times width, okay. Okay, so you can see, great. So this is the first thing that I wanted to do, which was just, and y, oh, you know what? It isn't 640 by 480. What is it? I forget. What's the Kinect version 2 width? I guess it's actually a little bit lower resolution. It's I forget what it is. Somebody might know. Image.width, image.height. Come on, console. Why come I'm not seeing anything in the console? Don't I have a print line there? Oh yeah, 512 by 424. I forgot about that. 512, 424. So this is working. You can see I'm getting, so I just wanted to do something first really quickly where I kind of make this grid, like lower resolution grid, because then what I can do is translate each one of those into 3D based on the brightness. And I'm pretty confident that I can do that in the video. So I think what I'm going to do, dare I just delete all this code because I'm going to write it again from scratch in the particular video. All right, that's what I'm going to do. Delete. Okay, so I'm going to just make a simple video where I look at looping through all the depth pixels and doing something with them. Any questions? 512 by 400. Thank you. Thank you for pointing out the errors. Wow, I've got a great number of live people today. That's wonderful. Okay, so and then I'll do one where I look at the raw depth data, I think. So I want to look at the difference between the color data and the raw depth data. But I think I'm going to try to do these small little chunks. Okay, here we go. I'm ready. Let me cycle these cameras. And I'm going to erase this diagram. I'm over here right now, by the way, people. I'm going to erase this because I probably need to do a quick pixel diagram for this video, especially if people haven't worked with pixel processing before. And now I'm ready. Okay. Here we go. Got my weird see-through T-shirt. You can see the guts that's like hole in my body. It's disturbing. Okay. So the same exact library will work with the Connect version 1 as well, and the techniques would be the same. I just happen to be demonstrating it with the Connect version 2, thinking that that would be a little bit more current. Okay. So let me stop here. I wish there was. Okay. That's fine, and okay. So I think I can make this a little bit smaller. I can minimize the browser here. Sorry, I'm just getting my window all set up. This one I can close, and I'm going to close this, and then go open. Come on. This one. Great. And make the console a little bit bigger. There we go. I think we're good. What about the font size? I feel like it needs to be a little bit bigger. It's looking a little small to me. That's a little bit better, right? Okay, here we go. The sun is coming. Sunlight is here today. Excellent. Hello, in this video, I'm going to look at how you can get the depth image from the Connect in processing and what you might do with that. So this is the very, very first step. I have a completely blank sort of like set of code here. I just filled a little bit in there in advance, but I'm going to write this program from scratch in this video. So if you didn't watch the previous... Hello. In this video, I'm going to look at how you get access to the depth image from the Microsoft Connect in processing and how you write some code to do some stuff with those pixels with that depth image. So if you missed the previous video, that's where I talked about the Connect in general, about how you install the processing library. One thing I did miss, which I think is important to mention, is that you do not need to install anything else if you're on Mac OS X. So the library just works. It comes with all of the libfree-next stuff sort of packaged inside of it. I believe on Windows there might be one other thing you have to install. Well, I should really look this up right now. Crap, I'm going to make this. I don't want to get this wrong in the video. Let's look this up. Here, Connect v2. For Windows 8, you have to install this driver, which I'll mention for the v2. Okay. I'm going to do this one more time. Okay, here we go. Hello, in this video I'm going to look at how you can work with the depth image from the Microsoft Connect in processing. I need my prop. I need my prop. I swear this is the last time I'm doing this. I just feel like having the prop will be good. It's stuck underneath the table. Help! It's funny how I've left my phone on. Periscope is still like streaming an index card. I don't know if there's anybody there. Okay. Okay. I swear this is the last time I'm making this video now. Come something. Hello, I have a prop. In this video, I'm going to look at how do you use this. I'm going to actually look at the code for using this Microsoft Connect in processing using the Open Connect for Processing library. Now, one thing I want to mention that I did not mention in the previous video is if you install the OpenConnect for Processing library, you need nothing else whatsoever. It just works with the Connect. There is one exception on Windows 8 with the Connect version 2. You do need to install an extra driver libusk. I will put that in the description below. So this is the Connect version 1, model 1414. It would work with this example, but I'm going to show you instead I have the Connect version 2 over here. And you can see the only code that I filled in so far is having a variable called Connect2. So if you're using the Connect version 1, the only thing you would change, this code would work mostly identically, is just say Connect instead of Connect2. So it's not Connect1 and Connect2, it's just Connect and Connect2. I'm pretty sure about that. If I get that wrong, somebody will correct me. Okay, so let's look at how you get started. So I filled in a little bit of code, but the only things that you need really to get started are an import statement at the top. That import statement is saying, hey, I'm here to use this library. You need to declare a variable. This variable is going to hold all the information about this Connect that you are using. So it's the thing that you're going to create, and I create it by saying new Connect to this. Now, there is a way to use multiple Connects, to use a version 1 and a version 2 to specify which Connect you want to use. That's beyond the scope of what I'm doing here. In this video, I'm only going to look at you just have one Connect connected to your computer. It's the default one. All you need to do is say equals new Connect to this. So once you've got that going, what is the next step? Well, you need to decide what it is you want to do. And in this example, all I want to do is use the depth image. So I'm going to say init depth. So the library doesn't start all of the feeds automatically. It's not going to start getting the infrared image, the raw depth, the depth image, the video image. It's only going to start using what you ask for. So in this case, I want to say init depth. And then I also want to say init device, which will kind of get things going. And by the way, this is where if I had multiple devices, I could put an argument in there to say init device 0, 1, or 2, that type of thing. So once I have that, I'm ready to go. And I can run this program, and we will see nothing on the screen. So, but a lot of stuff spit out here, which is kind of promising, device firmware, serial. The library is going to put a lot of stuff in the console, which is some basic information that you can see if it's working. It will say no, nothing connected if you don't have it connected. I realized some other things I forgot in the first video, but that's okay. Okay, so what's the next thing that you want to do? So let's just make sure things are working. One of the things the Connect gives you is that depth image, because I said init depth. So init depth, there are two ways I can look at the depth. I can look at the raw depth values with the Connect version 2. These are numbers between 0 and 4500. With the Connect version 1, these are numbers between 0 and 2048. These relate to millimeter measurements. But what I want is get depth image. And you can see what I'm doing here is I'm asking the Connect to give me this depth image and store it in a variable called image. And now what I can do is just draw that image on the screen to make sure things are working. So we can see here, and there it is. So there is the depth image. You can see I've got it, and now it's on the screen. So this is the goal of the library. It's pretty easy to work with in terms of just getting the data. So let's think about what you might want to do. So I think almost all of the, almost everything that you would do where you're working with the raw depth data or with the depth image involves iterating over all the pixels. You want to look at all the pixels and see which ones are the ones that are closest. You want to look at all the pixels and see what's the highest point of the closest thing. Or you want to look at all the pixels and say what's the sort of topology of the entire thing. So all of those statements I said involved look at all the pixels. So before I get to doing anything here, let's talk about what it means to look at all the pixels. So this is something that I've covered in some other videos, a whole set of videos about just image processing from JPEGs, PNGs, webcams, that sort of thing. And you can refer back to those. I'll make sure I link to those at this moment in the video. But just to remind you, if you have an image, whether it's a depth image or an RGB image, that image is a grid of pixels. And we typically, as human beings, look at this as a thing that's two-dimensional, and it has a bunch of columns, and it has a bunch of rows. And usually we think of the columns as the X values and the rows as the Y values. So you might think of this as the columns numbered, there's 5 columns numbered 0 through 4, and there's 4 columns numbered 0 through 3. And so if I were over here, this is pixel 3, 1. So this is how I think of pixels and images. And this is this image over here, this depth image, is a big grid of pixels, columns, and rows. The thing that you have to remember when working with stuff like this is that the computer is actually storing all of those depth values, all of those brightness depth values in this singular one-dimensional array. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. And those numbers correspond like this. The counting goes across, comes down here, comes down here, comes down here. So you can see I've got 20 pixels because I've got a 5 by 4 grid. 5 times 4 is 20. The pixels are numbers 0 through 19. So what we need is a methodology for if we're thinking of the x, y, how do I convert that to the location that's in this one-dimensional array, the index into that one-dimensional array? And the formula for doing that is x plus y times width. And you can see how that works, because if I look at this column index 2 over here, 2 plus 5 is 7, 7 plus 5 is 12, 12 plus 5 is 17. So the width defines those numbers as they go sort of down row by row by row. So if I say 3 plus 1 times 5, that's 3 plus 5, which is 8, and you can see that's 8 right here. So this is the formula that you're going to have to get used to, because what I'm going to add is loops. I'm going to say loop through every column and loop through every row to look at every spot in this depth array. So if I come back over here, we can now add that to our code. So for example, I can say right here, for every x from 0 to, and I'm going to say image.width, not I, and I'm going to say for every y. And again, if this idea of a nested loop is confusing to you, I will refer back to some previous videos about image processing. But what we can see, what I would like you to see here, is how this is the loop to say I want to look at every single depth pixel. So it could be I want to search for the closest one, or I want to search for the furthest away one, right? Or I want to just visualize every pixel in three-dimensional space. So for every x from 0 to the width, for every y from 0 to the height. And now what I could do is say, what is that index? How to apply that formula now? X plus y times image.width. And then the color is the color that's in that pixel, even though it's a depth value, it's turned into a grayscale color, is the image.pixels at that index. So this is now a loop that you will see in just about all the examples I intend to make today, where I'm looking at every single pixel and finding its index into the depth, into that depth image, and pulling out the color that's there. So what might I do with that? I could make a point in three-dimensional space. Let's do something here. Let's turn what we're seeing on the screen. Let me run this. Let's turn this into a lower resolution grid. So let's look, well, what I'm going to change this program to do right now is just look at every 10 pixels or every 20 pixels and draw a rectangle with that particular color there. So let's do that real quick. And I'm going to say, so one thing I'm going to do is I'm going to change this to brightness. I'm just going to look at the I'm going to look at the brightness of that pixel, which is just a single value between 0 and 255. And I want to draw a rectangle at x, y. Now, I'm going up by 1 pixel. So what I want to do, and you'll see this in some of my examples, is I want to introduce a variable called skip. And I'll say skip equals 20, because that's how many pixels I'm going to skip. Instead of looking at every single pixel right now, I'm going to look at every 20 pixels. Then I'm going to draw a rectangle at every 20 pixels, and I'm going to fill that rectangle with that particular color. So if we run this, we should see exactly what I had before, but just it's much lower resolution. So that you can see I'm still looking at all of the pixels, finding its color from the pixel array, and then drawing a rectangle of some size, arbitrary size 20 at that spot. So you can see as I move around in front of the Kinect, you can see my hands here, and you can start to see like, this is the kind of thing that computer vision-wise, it might be easy to pick out my hands as the sort of singular blobs of black shapes up in front. So, okay, so this is getting us started. Now, what's the thing that you might want to do next? Let's think about how you might turn this now into something that's three-dimensional. So what I might do here is say, like, first of all, I want this program. One thing I should note, by the way, is the Kinect, the depth image that you're getting from the Kinect version 2 has a width of 512 and a height of 424. With the version 1, it's actually 640 by 480, which is a little bit strange that it's higher resolution, but it's a little faster, a little more accurate here, I guess. There's like this beam of sunlight coming in, which is so lovely. Okay, so I'm going to add P3D because what I want now is for this program to actually start rendering something in 3D. The other thing that I'm going to need to do is add push matrix and pop matrix, because what I want to do is set the location of these squares, not by the coordinate of the rectangle, but through a translation, because ultimately I want to translate along the three-dimensional axis. So I use push matrix and pop matrix to save and restore that transformation state. These might be concepts that are unfamiliar to you. I will refer you to a different video about transformations, but you can see I have the same exact thing here. So instead of drawing the rectangle at xy, I've now translated to xy and drawn the rectangle at 0, 0. Why am I doing this? Because now I could add something, I could add a z here. So the first thing I might try is just say, okay, well, what is this z? Let's make this z equal to brightness. And you can see here, what do we got? We've got it's kind of hard to see, but you can see some rectangles are further in front than other ones that are further away. So the brighter ones are closer and the darker ones are further back. This isn't really doing me any good, because actually I think what might make more sense is to have the closer ones be more forward and the further ones be more behind. So I want to essentially position all these rectangles about where they actually are in physical space. And so to do that, I might use the map function, right? Because we know the brightness has a range between 0 and 255, but what I want is to now have a z value, this z value that's coming out of the screen. I want things that are dark to appear close and things that are bright to appear far away. So maybe I'll have the things that are dark to be at 150 units along the z-axis and the things that are bright to be at negative 150. So I'm taking that range that's between 0 and 255 and flipping it to have it map between 150 and negative 150. And then also, let's draw those rectangles a little bit smaller. And honestly, I think it might make sense to also just make them all white. So let's sort of see what we get here. Oh, and I have the image behind it. So you can see here as I come forward, boy, this isn't the best demonstration. Let me do something here. First, let me comment out drawing this image, and let's leave the colors back in, but let's invert the colors, which I'm just going to do that way. Try to make this a little bit better. So you can see here, the problem is there's this wall here, which is what you're seeing there. And something else is coming up. I skipped this version of Java. Let's see if I can turn the Kinect a little bit this way. And you can see as I go back, you can see as I come forward, we're getting these slightly larger rectangles. Now there's a moment actually where the Kinect stops seeing anything, and that's if I go way too close to it. But since it's giving me a value of 0, it's actually still working here. So you can see that as I move the hand, the things are coming closer. And maybe this range isn't so great. I should have practiced this beforehand. So let's make that range a bit more extreme. And you can see, this is getting a little bit better now. So you can see as I come forward, these rectangles get a little bigger. There's a lot of noise here. I don't have this Kinect in sort of a nice spot because there's all this other stuff in the room, like this wall and this table and this laptop. But you can kind of see my form here and my hands there as they come forward. So this is the basic idea of how you might start working with the Kinect. I'm going to try to show you some more practical uses of the Kinect in the next set of videos, but this is the basic idea of looping through all the pixels, looking at their brightness value, and mapping it. Now the truth of the matter is, if I was really doing this, what I probably would want to do is actually just look at that raw depth data. If I'm trying to visualize the data in 3D, this is not exactly the quote-unquote correct way of doing it. So that's what I'm going to show you in the next video, how instead of using the depth image, how you might make use of the raw depth data, those numbers which are between 0 and 4,500. Okay, thanks for watching, and I'll maybe see you in the next video. Okay, Okay. So is it in Connect? I'm seeing some in the chat. I wonder if with the Connect version 1, it's not init device, which is something that I'm learning right now. Let's go. Let me open up one of the examples for the Connect version 1. Yeah, I don't think you actually need the init device for the Connect version 1. I'm looking at the example right now. The init depth and init video stuff just turns it on. So I think you don't need that function. Let me open that. I'm looking in the chat to see if there are any more. The depth range is different, I believe, between the two models. I believe the second version has a longer depth range. Yeah. Okay, so that wasn't my best work. Okay, so I'm trying to think. I'm trying to think of what would be most useful to do next. I said I was going to look at the raw depth data. So I think I will. And then maybe with the raw depth data, I'm going to do a thresholding thing where I'm going to only show you pixels between certain distances. And in that sense, I'm going to get just the human form. I wonder if I should do that in advance. Who's coming to get me, Victor? Okay. I'm trying to think of what else I might be missing. Yeah, okay. All right. Okay, sorry everybody, I'm spaced out for a second. Everybody doing okay? Sirens. Oh yes, the sirens are coming to get me, thank you. Okay, so let's go on to the next topic. What I'm gonna do is open recent. So I think I'm not gonna build this one from scratch. This one I have ready in advance, which is just doing the point cloud. Why did this break? I had this working a second ago. Oh, something's already running, that's why. Yeah, so this is a more accurate way of doing the thing that I did in the previous one. So I think I will show this example, which uses the raw depth data, and then I'm going to use that to do some sort of thresholding as well. So I will change this into something else. Okay, I think my live stream is like way behind me. Like 10 minutes behind. But who knows? Okay. I better get on to the next topic. So let me close this one. Okay. Okay, point cloud. Sorry, everybody. I'm just getting this ready. Oh, that's funny. Because the X and the Y. Okay. Hold on, I'm doing something here. Okay. Okay, this is going to do. And I'm going to have that go a lot slower. Okay, sorry, I'm ready for the next video. Let me cycle the cameras. And drink a little water. My phone battery must have died by now. Let me see where the... Okay, here we go, everybody. Okay, start over. I need a little energy boost here. Should have gotten more coffee this morning. Okay. Hello. In this video, I want to blah, blah, blah. Hello. In this video, that hello is like a little bit creepy. Hello. In this video, I plan and hope and am excited to look at the raw depth data, meaning not the depth image, not the depth values converted to a grayscale image, but actually the raw depth data that's coming out of the Kinect itself. So again, with the version 2 Kinect, you're getting numbers between 0 and 4500. With the version 1 Kinect, you're getting numbers between 0 and 2048. And to demonstrate this, what I have over here is a simple processing sketch that's drawing a whole lot of dots on a plane in three-dimensional space, and that plane is rotating rather slowly. So what I want to do is, and this is what's known as a point cloud, I want to take every point on this plane and give it its actual physical real space. No, wait. Let's say that again. Okay, the Kinect is seeing all of these points. I am all of these points in a room. And the Kinect is seeing me, and I want to move these points around. This is like the weirdest thing I've ever had to explain, and it's like totally simple, and it would just make sense if I just showed it to you, yet I insist on trying to explain it in this weird way. But I want to take all the points that the Kinect are seeing in this physical three-dimensional space where I am, and I want to move these virtual dots, which are on the screen, in this virtual 3D space, and that's known as a point cloud. This is how you might start to build a 3D model of what the Kinect is seeing in the space. So the key difference here, so one thing that I had before in the previous video is we were looking at this pixel-based image, right? This idea of each image, each pixel of the depth image has a value between 0 and 255. And it's a brightness value based on how far or close it is. Now, the information is stored in exactly the same way inside of this, a big array, but instead the numbers are between 0 and 4500. So how do we work with these numbers? So let's come over here, and I'm going to do a couple things in this video, but this first point cloud example, I mostly have the code already. So you can see here that what I'm doing is looping through the Kinect's width and height. Again, I'm skipping because I don't need to do every single point. I don't need to do all of the points just to visually get this effect. And then I'm finding the offset into that array. So x plus y times Kinect2 dot width. So that's how I'm going to look up into that big array of all those depth values. Now, what is that array? That array I get that array by saying Kinect2 dot get raw depth. So when I said get depth image, that gives me a p image object with pixel values all in it. Now I just get a big integer array. Again, those integers are between 0 and 4500. So they're in that array, and I can say the depth is, I already used, the depth is the offset into that array. Now, there's something else going on now in this function. What it's doing is there's a function here called depth to point cloud position, x, y, d. X is the pixel x, y is the pixel y, d is the depth that the Kinect is seeing. There's a strange thing that's happening, which is that the pixel, we look at all these pixels in a grid, and we get this raw depth value, but the Kinect itself there's some math involved in how that can actually convert it to real measurements in physical space. Like where is the actual x, where's the actual y, based on like how the camera is seeing it. So in order to do that, this particular example has just this function, which essentially you'll want to download these examples and copy this verbatim. But this function is using all of these kind of parameters that are built into the hardware itself. So these are like a whole set of numbers and values that are just part of the Kinect's calibration, and you kind of multiply and divide by these numbers and you get the actual value of where it is in space. It's sort of an interesting problem. I would love to like go through it at some point, but right now I'm sort of inclined to sort of skip it and say the interesting thing is what you're getting is if you give the raw depth value, the pixel x and the pixel y, and use that function, you're going to get the x, y, and depth values in millimeters back of where those things are in physical space. So I don't want to, in fact, draw this is what you're seeing in this particular visualization right now is just all of these pixels at their exact x, y, and x, y value with a 0 depth. So what I want to do is change this program to say this actual physical point, this p vector, the p vector is an object that has an x, a y, and a z. I want to draw the vertex at point.x, point.y, and now point.z. And in order to make this a little bit better, I'm going to skip fewer pixels. I'm going to skip only 4. And I'm going to run this again. And now you'll see, here I am. This is the point cloud. This is me in 3-dimensional space. So if I zoom in on this, you can start to see like what's going on. This over here, by the way, is the wall. It's funny how I can like put my hands on the wall. It's almost as if I'm distorting the wall, but really what I'm doing is I'm casting a shadow. So it's a little bit strange to see this view of me and my Kinect. I can like, no, I wouldn't give myself a hug. That's a little bit weird too. I was like, punching was weird, hugging, anything that you do, I don't know. Just scratch all that. But you can see here, this is now a visualization in 3-dimensional space. So you could connect these points with lines. You could color them. There's a way of actually getting the RGB values. And so you could see like the colors that are on my shirt on these points as well. This is a road you could go down. And I find this road to be particularly interesting. But what, you can see that I'm using just a simple Y rotation, so now I'm kind of like spinning around this image, which has now gone off screen. But if I zoom back in, you can sort of see it's over there. So this is kind of the start of sort of thinking of like, what can you do with these raw depth values? I think what would be a useful demonstration now is to look at how might I actually pick out just me. So you can visually see just me, but there's a sort of mess. There's like all this stuff over here. There's this over here. There's actually like this pole over here that's being picked up by the Kinect. So what if I just wanted to like even only get my hand right here? What I want to do is try to calibrate a threshold. So what if I want the Kinect only to see, the Kinect's over here, remember? So it's to the left of me. I don't know what side that is you're viewing. But what if I want to say only look at the pixels in between here and here? And that would conceivably get my hand, right? How would I do that? How would I only look at the pixels between a certain minimum and a certain maximum? Let's look at that. So one thing I'm going to do is I'm going to save this as, I don't know what to call this, min-max threshold. And I'm going to get rid of all this 3D stuff for right now. Because I'm not going to do this with, you could do this with visualizing the point cloud still, but I'm going to do this with just, and I'm going to look at all the pixels. So I want to do x++ and y++. And somebody remind me, what's the size for 512, 484? Is that right? I don't know if that's right. And so hopefully that's right. And then what I want to do is, I don't need end shape. I don't need begin shape. I don't need any of this stuff. What I want to do, again, and I don't need this depth to point cloud thing, I'm taking all of that out. Because what I want to do right now is just go through this double nested loop and look at every depth value. 0 and 4,500, but I only want to like count the ones that are between 200 and 400, or between 500 and 800. What is that? What's that minimum and what's that maximum threshold? Okay, let's make this happen. So the first thing that I should do probably is I would like to make myself, just to be able to see this, I'm going to make myself an image. And I'm going to create a blank image, which is the same as the width and height of the Kinect. and it's an RGB image. So this is a function in processing create image that just makes a blank image. And then, and then what I'm going to do right now is I am going to, in here, right here, I'm going to say image.load pixels, because I want to operate, I need to operate on the pixels of that image. I'm going to set pixels in that image based on the raw depth. And at the end, I'm going to need to say image.update pixels. And I'm also then going to want to draw that image. So just to make sure that things are working, what I'm going to do is right here inside, this is where all of the important code needs to happen right now. It needs to happen right here inside this double loop, right? For every x, for every y, I want to set a pixel in the image. Image.pixels index offset equals, and I'm just going to set it to be, you know, some color right now, some purplish color, and run this, and we should see that that's working. Okay, so you can see this purplish color. I clearly got the size of the window wrong. Let me just get that for you guys really quick. So if I go back and look at my RGB depth test, this isn't telling me. Oh, actually, you know what? Let's just be smart about this. I want to just know what those values are. I'm going to print out the depth width and the depth height really quickly. We can look in the console. 512, 424. I knew I was close. So let me just get that right now. And I don't need this much of the console here. And I can get back to the important part of the code. We can run this. We can see, OK, purple. So I have now filled every pixel on the screen with purple. But what I want to do is fill every pixel on the screen based on the depth. So for example, what if I were to just say, if D is greater than 300 and D is less than 1500, image.pixels offset is that, otherwise image.pixels offset is black. So what I'm doing is I'm saying only if the distance is between 300 and 1500, let me see a purple color, otherwise let me see a black color. And when I run this, we should see, oh my God, I can't believe what I guessed. I'm like a genius here. I somehow guessed a pretty reasonable threshold. So you can see here that now what I've done, and now you see like all computer vision problems melt away in a way. What I could do now is like it's so easy to find the, I mean not easy, but it's much easier now to find the contours. I have this problem of this wall over here. So how do I get rid of this wall? Well, first of all, the real way that I get rid of that wall is by not doing my connect stuff right next to a wall. So unfortunately, this is like I need a better setup, I think, for doing these videos, which someday maybe I will find. But what I want to do, let's at least see if I can get the hands. So one thing you'll notice here is that the hands go away once you're about 1.5 feet from the connect. So what I really want is between about, I don't know, between 0 and maybe like 500. So there's probably a better way for me to calibrate this than just randomly picking numbers. But let's give this a try. You can see nothing, 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 nothing. Oh, that didn't do any good. So, let's. Whoops, that's not going to do me any good either. Let's do between like 200 and 1,000. Nothing. You can see right. But if I come in a bit, so you can see here how like I'm able to pick out only my hand. Again, I've got this problem with the wall. So I'm going to do something about that in a second. To maybe try to just not look at the pixels on this side of the window, I guess. But you can see how I'm starting to find this idea of a minimum and a maximum threshold. And really, I should make these variables. So I'm going to say min thresh is 200 and max thresh is 1,000. And I might as well make these floats, because what could be also useful, I think the way I could calibrate this, right? Here's a great way I could calibrate this. So in between the minimum threshold and the maximum threshold, what I might do is up here, I might say min threshold equals map the mouse's x value, which goes between 0 and width, to between 0 and 4,500. And the maximum threshold, I'm going to do y, which between 0 and height, 0 and 4,500, and then I'm just going to print out those values. I could draw them on the screen, which would probably be, let's draw them on the screen. So then down here, I'm going to just fill 255, text size 32, text min thresh plus oh, I got to use double quotes, max thresh, 10, 64. So here we should see on the screen these values. So now what I need to do is figure out like what's a good, x is going between, I've lost what I'm doing. Something is wrong here. Mouse x between, oh, this is max thresh. Yeah, that's a problem. Okay, so now you can see I'm able to like calibrate the minimum threshold. And let's calibrate the maximum threshold, like how far back am I seeing? But the minimum needs to be higher, and then I don't want to see too far back. So there we go. So this I feel like is good. If I'm getting my hand right now, it's between about 480 and 827. So let's, like only if I'm standing right here, of course. But you could design an interactive exhibit where you put some footprints on the floor and the person has to stand there. So I'm now going to keep my hand, boy, this is a long video, I'm at 15 minutes. I'm going to keep my hand around here, and I'm going to make the minimum and maximum 480 and 830. So now I can comment these lines of code out, and I'm going to say 480 and 830. And I'm going to run this again. And we can see I'm getting my hand like really, I'm getting pretty good tracking of my hand. So one thing that I'm going to do now, of course, which I think would be useful, is try to get rid of this wall over here. So, the wall is a bit of a problem, but I can kind of do a little bit of a cheat here, I think, which is also to say if and x is greater than, I don't know how many pixels do you think that was? That was probably about 75 pixels. So maybe it's a little bit more. So I'm just like not allowing me to measure anything that's like 100 pixels over. So you can see I kind of got rid of that wall, and now I have my hand. So this is great. You can see like this really nice, clean outline of my hand because this is my other hand coming in. It's not inside until it gets there, right? It's outside of that maximum threshold, and now it's inside of that minimum threshold. It's funny how it like, oh no, my arm is coming in. So of course, if my whole body comes in, now you can see my whole body is here, which is another thing that I want to look at. So you can see how this minimum and maximum threshold is working pretty well. So I think this wraps up this video. I'm going to continue this exact example. You could try this on your own as an exercise before you get to the next video. How would I actually just find the center of my hand? So I could control a processing sketch now by moving my hand around, or moving this hand around, or what if I do both hands? So how would I do that? I feel like I'm some sort of like magic person here. So that's what I'm going to look at in the next video. How do I find the center of my hand and control something else like a little like snake that's moving around the screen, or make a particle system come out of my hand? We'll look at that in the next video. And another thing I want to look at is how would I find the top of my head? So if I'm the human being here, how do I know if I'm bending down or standing up? Okay, so we'll look at that in the next video. Thanks for sticking with me here. I think this is actually starting to come together. Okay. All right, chat. Is anybody there? Okay, how is the hand edge drawn in black? Okay, 424. You guys are telling me in the chat. You're so nice. Boy, the live stream is like way behind me, I think. Oh no, I've DVR. I'm behind. Okay, I don't need to. Sorry. How's everybody doing? I've got to refresh this page. That's my problem. Oh no, I just need to be here. Ah, no wonder I'm in the wrong place. Sorry, everybody. I got to close this. Come back here. There is 23 people watching. Hi, Sean. Welcome, everyone. I'm about to do, in the next video, I'm going to demonstrate how to find the center of my hand. And then I'll make a particle system come out of it, which I think will be loads of fun for all the family. It's a family holiday, family edition of the Coding Rainbow today and Thanksgiving. I'm going to drink a little water here. I got to cycle the cameras. Okay. So I'm just about ready. I'm seeing if there's somebody asked, when do you think you can upload the videos? I will most likely upload the videos by the end of the day today, tonight, or certainly tomorrow morning. I'm going to do it as soon as I can. And if they're not there, you can always tweet. But this will always be there. This will automatically be archived and on YouTube, this like long thing. But so far I've made 3 videos. They're each about 15 minutes. Those will be uploaded tonight. Sean's asking if anyone ordered me pizza yet. First of all, I don't eat dairy, so don't order me a pizza. A little like, vegan tofu quinoa salad thing is like more my speed. But don't order me any food. I'm fine. I ate a big breakfast. I'm feeling good. Probably this Thanksgiving thing's going to happen tomorrow, and I'm going to have to eat this like giant meal. So don't worry about me. I'm fine. Okay. What was I going to say? I don't remember. I think I'm ready for the next video. Okay. So in this next one, what I'm going to do is look at how to find the center of my hand. Right, we did this thresholding here, and now I'm going to find the center of my hand. And let me get a particle system example open. It's probably overkill for me to bring that in, but it's let's do it. It's totally worth it. So I'm going to go under Topics, Simulate a Simple Particle System. I'm going to change something here really quick about this particular example. I really wish I didn't make the example the way that I made it. Yeah, what did I do? Oh, add particle. Shift-Man. Okay, let's see if this works. Okay, so I'm going to make these particles come out of my hand as I move. That's going to be fantastic. Okay? That's going to be the next example. Yeah, read only, schmeed only. Okay, so I'm going to go back to min-max threshold, and here we go. I'm going to hit run here, and I'm ready to do this video. Thanks for sticking around, both XP. Goodbye, Cardiff, England, Wales, which is part of the UK, and whatever. My geography is off, sorry. Okay, here we go. Ready? Did I cycle the cameras? Does anyone remember if I did that? I don't remember, so I'm going to do that. Let's see. Ooh, I'm running low on battery for the microphones, but I think I've got a full bar, and I've got 3 bars on the one in my pocket, so it should be okay. Try to keep an eye on that. And over here, if I stand about here, that's where the hands are. Okay, great. Okay, here we go. In 3. I'm going to close this. In 3. I have to press the button. There's nobody here to press the button but me. Hello. In this video, I'm going to demonstrate some really basic hand tracking with the Kinect, and I'm going to make a particle system come out of my hand. That's what we're going to look at in this particular video. So in the previous video, what I did is create this sketch where I calibrated a minimum threshold and a maximum threshold. So I'm only looking at depth pixels between those values. So if I stand exactly here and move my hand around, you can kind of see a pretty clean outline of my hand. Of course, this breaks down if I stand too close or if I stand too far away, but and so I should mention that ultimately this type of hand tracking might be better suited for the official Microsoft SDK, and I'll get to that eventually using a PC and a different Processing Kinect library, but I think it's still nice to see these examples of how you can do this stuff with the raw depth. Okay, so let's look at how you might do this. So this is where we are. We're looking for all pixels that are in between a minimum threshold and a maximum threshold. So how might I find the center of all of those pixels? Right here in the center of my hand. Well, the way that you find the center of something, sometimes called the centroid, if you want to sound like you're from the future, let's look at the centroid, is by finding the average location. So let's say we have a collection of pixels, that are loosely, this is some strange like 3-fingered hand, right? These are all the pixels we care about. We can plainly see that this is about around the center. But how would I find out the average? Well, let's say you just had these x values. This is the x value 0, 3, 4, 8, 12. To find the average of some numbers, add them all together and then divide by the total. 0 plus 3 plus 4 plus 8 plus 12 divided by 1, 2, 3, 4, 5 divided by 5 is the average. So if we add all x's and we add all y's and we divide by total pixels, not the total pixels in the entire image, just the pixels that we've picked out that are in between this minimum and maximum threshold. Then we'll find the center of that area of pixels. So let's look at that. How do we, inside that loop, add up all the x's, add up all the y's, divide by the total number of pixels? It's actually a pretty simple thing to do. This might be the shortest video I've ever made. I'm going to start. I need some value to keep track of the sum of all the x pixels, so I'll add that in. Then I need another variable to keep track of summing up all the y pixels, so I'll add that in. Then what I also need is just a total pixels, 0. Now I'm making all of these floats because I think it's going to be a bit more accurate to use floating point math. It doesn't really matter. They're technically they're integers. There's no like pixel 3.21, but it's a little simpler to work with floats. So this value is where I'm going to add up all the x's. This value is where we're going to add up all the y's. This is going to be the total number of pixels. Remember, that's not a fixed number. Like depending on where my hand is, how many pixels is it picking up? That's going to be the total. Once I have that, I can divide some x by total, some y by total, and that's going to be average x and average y. So let's look at that. So right here, these are the pixels that count, right? These pixels right here are the ones that are pink. Those are the ones that are between the minimum and maximum threshold. That x is greater than 100 was just to get rid of the wall that's over here because the wall is 100 pixels and over. So in order to do that, now I'm going to say right in here, I'm going to say sum x plus equal x, sum y plus equal y. Like I'm literally just adding up all the x's, adding up all the y's, and then total pixels plus plus. So for every single pixel, just add 1. I need to add up the x values for the x, the y values for the y, and then figure out how many pixels are there. And then at the end, what do I got? I don't need to draw this text on the screen anymore. What do I need to say? I need to say the average x, right? The average x is the sum x divided by the total pixels. The average y is sum y divided by total pixels. And then now, why don't I just draw, let's make this a different color. Why don't I draw an ellipse at average x, average y, and 100, I don't know, what size should that ellipse be? 64 by 64. So let's run this. You can see there's a circle. It's kind of going crazy, right? Because there's nothing in. But now you can see that circle is always around the center of my hand. Now, one thing to notice, if I put two hands here, it's the center of each. So in a minute, maybe I'll talk about how I might deal with that. But you can see now now it's not the center of my hand. It's the center of all the pixels it's seeing. So if my arm is in here, it's getting the center. But if I position my hand in a pretty good spot, you can see that I can get some pretty accurate thing going on here. So let's make it do something a little bit more interesting, just for the sake of, I don't know. I don't know if there's a huge point to this, but here's, whoops, didn't I just fix this? What's wrong here? Everybody, I did this a second ago. It's fine. So this is an example of a particle system where all the particles are coming out where the mouse is. And you can see right here in the code, there's just a little bit of a simple line of code that says add particle at mouse x, mouse y, right? So it's just as easy now as bringing all this particle system code over and saying, instead of adding the particles at mouse x, mouse y, add them at average x, average y. So let's see if we can make that happen. I'm going to do a quick little, I should have probably do like the cooking show thing where I have, and now coming out of the oven, I already pre-made this. But I'm just going to copy paste everything over real quickly. I'm going to bring the particle system object. I'm going to put this in my setup over here. And I'm going to put this stuff in draw. And at the end here. And then what do I need? I need all this particle code. So I don't actually need this camera params tab for this example. Hold on. Hand tracking sort of particles. I don't know what to call this. I'm going to get rid of this tab, camera params. And then I'm going to add a new tab. I really shouldn't be doing this in the video. I think I crashed processing. Hold on. No, everything's fine. I'm going to add a new tab called, this was not good. You fast forward a minute. I'm going to move the particle system over. That was the particle class. And I'm going to do, it doesn't matter. I'm going to move the particle over. Just imagine that I did that correctly. I'm going to run this. We can see, right, the particles, the circle is following my hand, the particles are following the mouse. How do I make those do the same exact thing? Now all I need to do is say, make the particles not at the mouse, but at average x, average y. And you know what? Let's actually add about 10 particles per frame to make it kind of make more particles. And let's run this, and we can see now as I put my hand here, I can like control where the particle, I can make this like fiery thing come out of my, it's not fiery, but come out of my hand. So you can see I'm now using my hand to control particles coming out. Now I can do my ta-da dance. And it works with anything. Like I can have like this stuff like emanating from my it's like alien and like bursting out or something. I don't know, this is all getting a little bit weird. But you can see I can strike this pose, and it's running kind of slow because I'm drawing like so many circles on the screen. It was a little bit unnecessary to like do that much, but you can see. Anyway, so I can make the particles move faster. You can get where this is going here. So this is one example of what you can do by having a kind of specific setup, knowing where all the pixels are, thresholding them, finding the center of something. This is what you can do. Now, let me say a couple more things before I go into the next scenario. Number one, and let's turn the particles off for a second. Number one is we have this issue of one hand, two hands, the thing in the center. On one hand, this is kind of cool. I'm like, I am a magician levitating a ball around the... I forgot that I was making a video for a second. On one hand, that's sort of an effect on its own, feature, not a bug type thing. On the other hand, you might actually want to have a circle for each hand. And in that sense, you need to employ a more sophisticated blob detection mechanism. For example, you don't want just the average of all of the pixels. You want the average of a bunch of pixels, but don't include pixels that are over a certain distance threshold from other ones. So this is something that I could potentially demonstrate in a future video in this series. I'd be happy to add one in. But also in this case, one thing you can do, if you have this very clean image, you can pass it to a library that might do that type of edge detection, blob detection, contour detection for you. And there's two libraries, I'll try to link to them in the description, that I might recommend. One is called blob detection, does kind of what you're thinking. Another library is called OpenCV, which has a lot of computer vision functionality built into it, but one of the things in it is blob detection. So maybe I'll try to like show that at a certain point, but you can see the basic idea here is still just working even without an extra sophisticated layer of looking for separate chunks. Okay, thanks for watching this. I think in the next video, I have two more that I intended to do today, although it is 12:10. I wanted to see if I could look at, for the top, like how do you find the highest pixel? Or the closest pixel is something you could also find, but I think highest might be interesting because somebody here at ITP has a project that she's working on, which is having somebody move up and down, so I think that's a useful demonstration. And then also maybe looking back at that grid again, but averaging all of the depth points within cells of a grid. Okay, that's what I intend to make next. I'm going to hit stop on the record button. Come on, wake up. Okay, everyone. All right, everyone. Yeah, I see some people are chatting about me in the stream. It is true, actually. I didn't actually start programming until 2001. I was 27 years old, 2001. You can figure out how old I am now. I did take some programming classes in middle school. Assembly language and basic. I also took an evening C++ course once because I thought it might be interesting in programming, and I was like, didn't like it. But then I think being in a creative environment like ITP, I got kind of obsessed with it. So that is true. Okay, so I forgot when I have to check when my office hours are because I have to go soon, unfortunately. I have to grab something to eat before. I'm looking this up right now. They start at Schiffman, where's Schiffman? At 1, I'm not going to give the time. Okay. Yeah, 1:20. I need to take a break, obviously, but to eat something between them. So I think I could manage a little bit more because I want to do, I think I could try to do these two examples real quick. So let's look at the, yeah, there's a problem where I need to file, OpenCV is not showing up in Processing 3, but it actually works in Processing 3. It probably just needs a few little fixes. I would love to, Greg Bornstein, who did a tremendous amount of work creating this library, I should look at it and see if I can just put a pull request quickly on GitHub to make sure that it shows up in Processing 3, because it does work in Processing 3. There's probably just a few little things that need to be fixed. Okay, I'm gonna get a little more water. I'm going out into the hallway, and I'll be right back. Okay. Are you watching this from here? Okay. You were. I'm sorry. Thanks, Sean. Okay. Okay, I'm back, everybody. I'm going to just get a little cool air in here for a second. I'm going to turn off and on the cameras. Oh, I have to go around this side. Okay. Let's see here. I'm over here. I'm going to erase. So the next video that I'm going to make here. Oh, wow, there's quite a glare from the sunshine over here. I wonder if I write over here if you can't see it. Yeah, you can't see that very well, so I'll just be conscientious of that. I just can't bear to like black out the window in this room. I did that last year, and it's like miserable to be in here. So I'd much rather have the sun infecting me. Let's see. Okay, this is pretty good. Okay, so in this next video, the next thing that I'm going to do is look for the closest point or the top of someone's head, the highest point, that type of thing, which is a kind of common algorithm in computer vision that you need. Oh yeah, right. There's a hot mic again. Okay, and here we go. I got to close the window. I'm gonna try to do this, by the way, for 15 more minutes. I don't know if I can get through both of these topics in 15 more minutes. And then I have to go. I guess I've been doing this for 1 hour and 36 minutes so far. Okay, here we go. Water's here. And I'm getting myself ready. I cycled the cameras. Didn't I just do that? Right? I can't remember. I can do it again. I'm going to check the battery is at 1 bar still, so my mic shouldn't go out in the middle of this. Okay. Hello. In this video, I'm going to look at how you might, using the Kinect, find the closest thing in the room or the highest thing in the room. This type of algorithm is kind of common in a lot of computer vision applications, I think, which involves similar. Hi. In this video, I want to look at an algorithm that lets you do the kinds of things like find the closest thing in the room, or find, I'm doing all sorts of like Vogue poses, find the highest thing in the room. I don't know why I need to do that for the highest thing, but whatever. And this is a similar type of algorithm if you've ever looked at like a color tracking algorithm, find the brightest thing or find the most red thing in the room. I like to refer to this as like the world record algorithm, which means like I've got to look at every single pixel and keep track of which pixel is the record holder and hold on to that record holder, the closest thing, the highest thing, the most red thing, and when I get to the end, have that XY coordinate that I can use for something else. So a lot of things that you might do with the raw depth data of the Kinect could involve this, like if you know the person is always standing like this in a fencing pose, where is their hand? Because their hand is always the closest thing. Or if you want to determine if a person is moving up and down, how do you find the top of their head? What's the highest thing within a given threshold? So let me go over to the whiteboard for a second to just talk in generally speaking about how this kind of algorithm works. And then we'll go and implement it in a couple different scenarios. Okay, so as with just about everything that involves images and pixels or depth points, you've got this grid, right? And the grid has a bunch of x's and a bunch of y's, and there's always this loop. All the examples have this. For every x, for every I, look at every pixel. Now I've got some glare here, so hopefully you're going to be able to see what I'm writing, but I was going to say shout at me. just shout at your computer screen or wherever you're watching this, and I will hopefully hear you someday. If you can't read what I'm about to write. But so the way that this works is you need to find the record holder. So let's say we wanted to find the closest thing. So remember, the depth values are between 0 and 4,500. So we could start by saying the initial record, right, the world record for the closest thing would be 4,500 because that's the furthest back. So any pixel that beats 4,500 is by definition the new record holder. So we have to say something like, if I have the current depth in a variable, I need to say if that depth is less than the record, then the record is now that depth. So this is the core algorithm for every pixel. Is the first one beating the record? It is. That's the record holder. Is the next one beating that record? No. Is the next one beating that record? No. Is the next one beating that record? Yes. Okay, that's the record holder. And while we're doing this, we could also keep track of, the record X and the record Y. So if every time we get that new record, we store that X and Y, so that by the time we get to the end of this loop, in those variables are the X and Y that win this record. So let's look at how we might do that. And I will come over here and let's do, okay, let me save this. I kind of want to do the closest thing, that's what we talked about, but you'll see that it's not going to work in the most perfect way. But let me save this as a closest thing. And I'm going to, I just want to delete the particle system tabs, which are no longer relevant. Oops, don't delete that tab. I think I made a mistake earlier. And I'm going to get rid of all this particle system stuff. Sorry, I should have done this before I started recording this, but it's too late now. We can get rid of all this particle system stuff. And I'm going to get rid of the average thing that was interesting that we were doing in the previous video. And even such, I'm going to keep this thresholding in here, because I think that's maybe a little bit useful to kind of keep at the moment. Actually, you know what? I'm going to take that thresholding out, but I'm going to keep this X is greater than 100. And what I would like to do is, too much going on that I didn't think to do in advance. It's okay, everything's fine. Just talk amongst yourselves for a minute or fast forward to like 30 seconds in this video and I will be at the point. So I just want to take out all this stuff. Let's keep the, yeah, this is fine. I know what I need to do. Everything's fine. I'm going to draw, I don't need this image anymore. Right, what I'm going to do is, what I want to have access to look at, sorry everybody, is the raw depth image. The depth image as well. So I'm going to call this the D image equals connect to dot get depth image. So that way I can draw that image on the screen. And so let's just make sure this is now working. So you can see, okay, I've got the depth image on the screen. So what I want to do now is look for the pixel that is the closest, okay? And we've got a bit of a problem here because some of these, there's a window back there and it's going to give me some weird 0 values. So I think this might not work. Oh, and I should have kept the thresholding. Crap. I should really, you know what? I'm gonna hit stop on the recorder for a second and I'm gonna just stitch this together from when I moved from over here. Ah, crap. I wasn't thinking straight there. Okay, I'm pausing for a second. All right. So let me figure this out here. Closest. Let's just see how this works. I'm going to build this. I'm going to pause the video. I should have checked this in advance. I'm going to close this. So what I'm doing now, I'm going to come back and record again in a second. What I'm doing here is, and I can delete all this stuff. I'm going to need that threshold again in a second. What I'm doing here is looking for, okay, so I need the record is 4,500, and the record X is 0, and the record Y is 0. And I'm going to say if D is less than record, then record equals D, record X equals X, record Y equals Y. And I need to close curly bracket, and then at the end of all this looping, I can say draw an ellipse at record X, record Y, that is some size, that's kind of big. And let's see how this goes. Okay, so you can see the problem is that it's always in the top left. It's a good thing. So what I should probably, okay, so one thing that I was going to do, right, is skip these pixels. Let's try this. And let's see, can I get it to be something? Problem is there's too much glare and reflection back there. So I should do the top. I should just do, oh, as I got over here, something became closer than what's back there, my head. Oh yeah, I'm kind of able to get this to work if I come really close. But not, it doesn't work so great because I really should be, there we go. Why is it if I move, I must have messed something up. Record Y equals Y, record X equals X. No, that's right. What I probably should do the top of the head thing. Why is it not? It's interesting how. So I think this is a bad demonstration, which is mostly because of the setup I have here. Like if I had the connector over here and had this flat wall behind me, it would work pretty well. I could look for the thing that's closest within a minimum maximum threshold, which is probably I should have kept that. But I think what I might do is put the threshold back in and look for the. I should put the threshold back in. So let me bring that back. Do I still have that here? So I want to say if. So let's bring the threshold back in. So I only want to consider stuff that's if D is greater than min thresh and D is less than max thresh and X is greater than 100, I think is what I had, then I can look for the record thresh. So this should, right now this is working. You can see how much it jumps around, but you can see it works with anything that's within that threshold that's closest, which right now if I bend down is also my head, but of course as I move out of the threshold. So you can see how like unstable this is, but I think that could sort of do the demonstration. I actually want now also to have that image back now, which is that I should say, what I should be doing is, I think this would be, hold on, you're kind all to stay, set the initial record to the highest possible. Didn't I do that? So what I want to do is put the image back in too. So image load pixels. So I'm going to say, image dot here. Let me turn off. I'm going to turn off the code completion. Else image dot pixels offset equals D image dot pixels offset, and I'm going to here say image dot pixels offset equals color 255-0150, and then this should be a different color. And then I need to draw that image also. Let's see. Whoa! Hello, Kinect. That is the weirdest thing I've ever seen. What just happened there? Whoa, what is going on? Oh, some other image is there. Whoa, what is going on? Oh, I didn't say image.update pixels. Must be why. There we go. So I should see like when the stuff is within the threshold, I'm finding the closest thing within the threshold, which might be like my elbow, that sort of thing. Maybe that minimum threshold should be actually like lower. Anyway, Okay, so sorry. Okay, I'm going to start this over, and I'm gonna start it. I'm gonna take this out, and I'm gonna take this out. This is the stuff that I'm gonna add in, and I'm gonna take this out. So now what it should be, I've just got something where it's showing only the threshold of pixels, but also all the rest of them. And then I really want to do the top of the head thing, because I think that might actually work much more accurately to find the highest pixel that's within the threshold. But I'll do the closest and then the top. Why not, right? Okay. So I now have to pretend, where was I? I was over here, and I was talking about this stuff, and then I finished and went over to the computer to talk about something else. So I'm going to do that again. Shoot. This is definitely going to be, whoops. This is definitely going to be, come back. This is definitely going to be it for today once I get through these two examples, because I'm like sort of late now. We have 45 minutes till my first appointment. I need to eat something in between. So, but I want to get through this, so to have this done. Okay, so here we go. I think I can do this now with this particular example. So I'm going to have to like cut this somehow. I hate it when I do editing. I'm not really going to do editing. I'm just going to splice these things together. And I'm going to pretend. OK, so I'm going to walk into the scene over here. I'm afraid. Am I recording this? I am. Yes. OK. OK, so to demonstrate this example now, what I have is I've adjusted this example a little bit. And what it's doing now is it's showing you both the depth image as well as coloring particular pixels of that depth image, this pink color that are within this threshold. So now I need to figure out what pixel in that threshold is perhaps a record holder of some sort of record. So we'll look at the closest thing and also the highest thing. And I'm pretty sure the closest thing is going to not work that well, but the highest thing I'm hoping is going to work pretty well. So let's do the thing that's not going to work as well first. And let's just look at a little bit of what's changed in the code just to show you. So first of all, I'm looking at the depth image as well. And then what I'm doing is if this depth value is in the threshold, I'm setting that particular color to this pink value. Or purple value, I don't know what color it is, I can't tell. If it's not, then I'm just pulling the color value from the depth image itself, then updating the pixels and drawing the depth image. So that is why you are seeing this particular result. It's essentially what I had earlier in the previous examples with just also adding in those depth pixels instead of black. So now we need to figure out this way of getting a record holder. So the first thing we need to do is say, at the beginning, what's the record distance? I'm looking for the thing that's closest. So the thing that's closest, the record to start would be something really, really high. So the record would be 4,500. That's as far as something is possible to be from the Connect. Then I need the record X, which will be at 0, and the record Y, which will be at 0. So I want to test every pixel X and Y if it beats the record. If it does beat the record, set Rx to that new X and set Ry to that new Y, and then draw a circle at that record value at the end. So right here, I'm going to check only inside the threshold. You know, in a different scenario where I had the Connect in like an open space and a sort of flat wall, and people just came into the middle, wouldn't really need to do this thresholding thing but there's so much stuff in this room. There's a desk, there's a computer, there's a wall that it's not so. I think using the threshold here helps it be a little bit more accurate. So I could say if that distance is less than the record, then the new record is that particular distance, right? For every single pixel, does that pixel beat the record? If it does, I've got a new record. And if it beats the record, then I need to save that particular X and Y in Rx and Ry. So all we need to do this kind of record algorithm is a starting record, a starting Rx and Ry, and then every time we beat that record, save those two values. And then at the end, I can draw a circle at Rx and Ry. And I'll just make that circle white, so we pick it up, and we can see now. Okay, now first of all, you can see that circle is just jumping around. That's because first of all, there's very little. There's like stray pixels that are making it in the threshold. So now you can see that it's kind of working now. You can see that white circle is following my hand. Now notice this is much less accurate than what I did before with this sort of average section of pixels. Mostly because anytime you're looking for a single pixel, it's not such a great thing. I kind of want to find a group of pixels that are like beating that record. But that aside, you can see the basic idea is working. But it's really like if I come and stand in here, like there's a lot of me that's in the threshold, but my head, as I'm bending over, is closer. So you can see if I move my hands out, they're a little bit closer. If my shoulder comes in, my shoulder is the closest thing. So you can see it's jumping around a lot, but it's always finding the particular pixel that is closest. It's just sort of demonstrating the idea, but let's change it now. Let's have it find, I'm going to stand here to sort of, let's have it find the pixel that's highest. And I'm a little worried we're going to have a little bit of an issue because you can see it's something jumping to the top. But let's see, because there might be some stray pixels that it's picking up that are kind of, but let's see if we can get it to work. So what is the record now? So the pixel that is highest could be 0. The record would start at the height of the screen. So I'm going to comment this out. I'm going to leave both of these in this example. I'll try to post this code somewhere where you could download it and put a link in the video description. So the record would now be the height of the window, or I could really say, it really makes sense here to say depth height. So that's the starting record. And now if inside this threshold, distance, that's not the depth, what I want to know is if y beats that record. So if this particular y pixel is just, I'm looking for any pixel inside that threshold that's very high, then I've beaten that record. So the record equals that y value, save this, save the x and the y, and then draw it. So the same exact idea, I'm just changing what the test is. Like the height is the y value if it's less than that record. So now we'll run this, and we can see it's picking up a lot of noise, but if I come in and bend down, so there's too many pixels up top. You can see that it's flickering. There's too many pixels up top that are pulling up some sort of value. So I'm going to try to do like a little bit of a hack here again. We're going to say and. I'm going to say let's skip the first like 50 pixels. I'm only going to look, and let's see if this helps. There we go. So now you can see I'm getting the top of my head pretty accurately. If I move my hand up here, I'm getting the top of my hand. So if I had a particular project that I wanted to have something move based on whether I'm moving up and down, this is good, I'm gonna do some extra squats here. You can see that this works. So, I had to sort of like calibrate and do some goofy things, but you can see this is a very simple way of just finding the top. So like people always get obsessed with like finger tracking. Like let me find the finger, but you can see how accurate this is. I'm just getting like the tip of my finger now. There's no finger tracking here. It's just like if I go like this, it's getting the top of my elbow. But if you tell people to stand like this and wave their finger, you can see how like kind of super accurate that tracking is just from looking. This is like the simplest thing ever. I'm just looking for the top pixel inside this threshold. So hopefully this shows you a few types of things you can do. We've seen a range of things of just sort of visualizing the 3D data, from like looking for thresholding it in between, for tracking the height of something, the average location. This is where I'm finishing this video set today. But there will be some more ones. I guess, who knows when you're watching this, the more ones might already exist, the more ones, and you'll see them in the next video. Okay, so thanks for watching. Oh yeah, right, and I will talk to you soon. Okay, goodbye. All right, everybody. So that's it for today. So if you have any questions, I can take questions for like maybe 5 minutes. It's 12:36, and I'm going to go in about 5 minutes. I can take questions, and then I'll go. Sorry, my brain is like totally fried. This has been 1 hour and 58 minutes that I've been on this live stream. So I'll give it a minute to see if anybody wants to ask anything. Whoops. See if anybody is okay. Any important info here? Okay. Let's see if anybody asks any questions. Any tips on using more than one Connect? What you want to do if you want to use more than one Connect is go look at the examples. In the examples, I'm going to come back up here under contributed contributed libraries under Open Connect. So this one here, multi-connect version, this one is showing you actually how to use more than one Connect and even a Connect version 1 and a Connect version 2 in the same sketch. And here under Connect 1, multi-connect, and here under Connect multi-connect 2. So for example, if I just come to multi-connect 2, you can see here that you can create 2 different Connect objects and then init them as init device 0 and init device 1, which will make them separate. So you can actually, everything works exactly the same way. It's pretty simple to be able to do that. Yeah. What is the update rate of Connect depth data? I'm pretty sure it's 60 frames per second, but I don't actually know. I bet you if you Google that, there'll be an answer on Stack Overflow or something. I would love to know the answer to that for sure. I seem to remember hearing 60 frames per second. I don't know that the first version 1 Connect is that, but I think the new one is. Okay. Oh, yes, sorry. So, okay, great. So this is technically how you could have more than one Connect hooked up to your computer, but you do have certain issues with, like, you point them at each other, the infrared light starts to interfere with each other. So trial and error is your best friend here. Sometimes it just seems to work anyway. Sometimes it can be a problem if you have a lot of sunlight, it can interfere. You can't put a mirror in the room because the mirror is going to reflect all the light. So there's a lot of issues around that. But for the most part, you can have 2 Connects. If they're pointed in different directions, then the infrared stuff doesn't cross. They'll definitely work. If they do cross, I feel like with the new version 2, they seem to operate on different frequencies or something, and it kind of still works anyway. But to be honest, I haven't done a lot of stuff with the Connect. I'm kind of just trying to teach it from making examples. But I haven't with the new Connect. I haven't really made a lot of projects with it. Okay, 2 hours is generally my limit. I hope next week I've got a real schedule problem, but I hope to be back to do at least one day next week, but it might not happen. But I'm going to be doing these, in January I might even do these live streams twice a week, I'm hoping. And then in February I'm going to be doing them a lot, is my plan. But keep in touch, ask questions over Twitter, put comments and questions in the YouTube videos is super helpful, especially if I mentioned something that I forgot to put in the description, or I could put an annotation in that corrects something. That's great. So please keep in touch, let me know. I hope this is helpful, and I will see you guys soon. I'm going to hit stop on this stream.